Let's discuss new question. Discuss the force, magnetic force on moving charge in magnetic field. We know when electric charge is there in electric field, electric force, electrostatic force F is equal to QE acts on the charge particle. Similarly, when charge particle is there in magnetic field, definitely magnetic field will act on that. We have to discuss about this magnetic force. Okay? Now listen. Suppose charge Q moves in magnetic field V with velocity V. Angle between velocity vector and magnetic field vector is theta. ठीक है? Magnetic force on this charge Q is the magnetic force on this charge Q is directly proportional to the magnitude of the charge. Okay. Similarly, it is directly proportional to the magnitude of the magnetic field, and it is directly proportional to the component of velocity which is perpendicular to magnetic field. Okay, component of the velocity which is perpendicular to magnetic field. Angle between velocity vector and magnetic field is theta. So if I divide velocity vector into two components, v cos theta component is along the direction of magnetic field and v sin theta is perpendicular to magnetic field. Okay, so magnetic force, this is from experimental study. Okay, the experimental study shows magnetic force on charge is directly proportional to its magnitude. Is directly proportional to magnitude of magnetic field, and is directly proportional to the component of velocity which is perpendicular to magnetic field. Okay, now from this we can conclude, so therefore magnetic force F is QVB sin theta. Okay, if I represent it in vector form, this magnetic force F is QV cross V. So when charge Q moves in magnetic field with velocity V, the magnetic force which acts on this charge is FQV cross V. Clear? Now, important points about this magnetic force. So, first point, magnetic force on stationary charge is 0. If charge is there in magnetic field Suppose the charge is there in magnetic field but it is stationary. In that case magnetic force is 0. But we know that it is not so in case of electric field. If stationary charge is there in electric field, definitely there is electrostatic force on that charge. But if electric charge is there in magnetic field, but if it is stationary, magnetic force is 0. Okay, magnetic force is 0. Second point you can conclude is, if velocity vector and magnetic field vector are parallel or anti-parallel, then magnetic force is 0. It is not like that if the charge is moving, then definitely 100% magnetic force will act. So from this it is very clear, though it is in motion, though the charge particle is in motion, but if the velocity vector and magnetic field vector are parallel or anti-parallel, in that case magnetic force is 0, because for two parallel vectors or two anti-parallel vectors cross product is 0. Third, when velocity vector and magnetic field are perpendicular, magnetic force is maximum. It is QVB. Okay, if they are perpendicular, if the theta is 90, we know that sine 90 1, that is the maximum value of sine. So because sine has maximum value, so corresponding force will have maximum value. Clear? So if velocity vector and magnetic field vector are perpendicular, then force is 0. Sorry, maximum. Okay. Now listen. Here, according to the property of the cross product, we know that A cross B, the direction of A cross B is perpendicular to vector A, is perpendicular to vector B. It is also perpendicular to that vector, that plane which contains vector A and B. So similarly, we can conclude that here that force, magnetic force is perpendicular to velocity, magnetic force is perpendicular to magnetic field. It is also perpendicular to the plane in which vector A and B are lying. Okay. So force vector, the direction of the force is perpendicular to velocity. Direction of the force is perpendicular to magnetic field, and it is also perpendicular to the plane in which A and B, here A is our velocity vector and magnetic field are lying. Clear? Fifth point. Clear? F is perpendicular to velocity. So this force is centripetal force. okay, which can change the direction of velocity but cannot change magnitude of velocity. मैग्नीट्यूड ऑफ वेलोसिटी का मतलब है स्पीड. We know that in 11th standard we have discussed this. If force is perpendicular to velocity, then this force is centripetal force, and centripetal force can change only the direction of velocity. It cannot change the magnitude of velocity. So magnetic force cannot change speed. Yes, electric field can change the speed. If the force of electric field is in the direction of motion, in that case speed increases. And if the force, electrostatic force, is in opposite direction to motion, if it is in opposite direction to motion, in that case you will find speed decreases. So electrostatic force can change the speed, but one thing we should notice, that magnetic force cannot change the magnitude of velocity. Means it cannot change the speed. It cannot change the speed. Okay. 6. Magnitude, speed remains constant. So kinetic energy gain due to magnetic force is 0. Kinetic energy will also remain constant. Right? So if the charged particle Q moves with velocity v, okay, in magnetic field B, so experimental study shows force is directly proportional to magnitude of the charge. Force is directly proportional to magnitude of the magnetic field, and it is directly proportional to the component of velocity which is perpendicular to magnetic field. So we have force Q V V sin theta. If I represent it in vector form, it is Q V cross B. Now let's discuss some important points about this magnetic force. So magnetic force, you can see if the velocity is 0, force 0. So force on stationary charge is 0. So magnetic force, if stationary charge is there in magnetic field, magnetic force 0. Suppose charge is not stationary, it is moving, okay, but if the velocity vector and magnetic field vector are parallel or anti-parallel, in that case your magnetic force is 0, because cross product of two parallel vectors or two anti-parallel vectors are 0. Okay. When velocity vector and magnetic field vector are perpendicular, you will find the magnitude of the magnetic force is maximum, because theta is 90 sin 91, which is maximum value of sine. Okay. Here one thing, according to the property of the cross product, the direction of the force is direction of the V cross B. So definitely it is the direction of V cross B. Okay. So force is perpendicular to velocity, force is perpendicular to magnetic field, force is also perpendicular to the plane in which velocity vector magnetic field vector are lying. Okay, because force is perpendicular to velocity, whenever force is perpendicular to velocity, this force can change only direction of velocity, it cannot change the magnitude. Okay, so this is centripetal force which is responsible for the change in velocity, change in the direction of velocity only. Okay, because speed remains constant, so definitely your kinetic energy will remain constant. So kinetic energy gained by the charged particle due to magnetic field, due to magnetic force is zero. So kinetic energy will remain constant. Due to magnetic force, kinetic energy of the charged particle will not change. Okay, so you can note down the question, read it carefully one more time. Next question is about Lorentz force. Okay. Next question is about Lorentz force. Okay. So let's discuss Lorentz force. What is Lorentz force? If electric charge moves in the region where electric field and magnetic field both are present, in that case, the resultant force on this charged particle is Lorentz force. Okay. If the charged particle moves in the region where both electric field and magnetic field are present, then the resultant force on this charge is Lorentz force. Okay. So if the charged particle is moving in the region where both electric field and magnetic field are present, then resultant force experienced by charged particle is called Lorentz force. Clear? If the charged particle is moving in the region where both electric field and magnetic field are present, then the resulting force experienced by the charged particle is called Lorentz force. Clear? Suppose charge Q moves with velocity v in the region where electric field E and magnetic field B are present. Clear? So electrostatic force on this charge Fe is QE. Clear? Electrostatic force on this charge is QE. Similarly, magnetic force on this charge is Q V cross B. It is the magnetic force. So therefore resultant force, which is called Lorentz force, is vector sum of electric force plus magnetic force. So FL is QE plus Q V cross B. So therefore Lorentz force can be represented as Q common vector E plus V cross B. Clear? So this is Lorentz force. Read it carefully. Next question. Define magnetic unit of magnetic field. Define unit of magnetic field, that is Tesla. Clear? Now F is QVB sin theta. Clear? So magnetic field B is F upon QV sin theta. Okay. If F is 1 Newton, Q is 1 Coulomb, V is 1 meter per second, and theta 90, then you will find B 1 unit, that is 1 Tesla. So from these we can define magnetic field. Magnitude of magnetic field due to which one Coulomb charge moving with 1 meter per second velocity perpendicular to magnetic field experiences 1 Newton magnetic force is called 1 Tesla magnetic field. ठीक है, magnitude of the magnetic field due to which 1 Coulomb charge moving with 1 meter per second velocity perpendicular to magnetic field experiences 1 Newton force is called 1 Tesla magnetic field. So F, from this F is equal to QVB sin theta. This is how you can define magnetic unit of the magnetic field Tesla. Note down the definition.